Hello, welcome back to the next session in our today morning slot about use cases. And for this, I'm very happy to welcome Cornelia Eitel from Hirschmann Automation and Rico Zoss from the Control GmbH and ANNAX Group. And both will give us a deep view inside applications for transportation and automation use cases. Thanks and very welcome, Cornelia and Rico, and the stage is yours for the next session about use cases.
Thank you very much, Matthias. I will try to to show my screen now. I hope everyone can see the screen.
Yeah, the screen is visible. First slide off.
Okay, so perhaps Rico, you would like to start?
Now it works.
The presentation. So, yes, weight loss without diet, how to achieve your dream weight with single pair Ethernet. And I think so now I will hand over to Rico, but I think so he's just muted.
Hello, Rico. I think you have to unmute your voice on this small button. Unfortunately, we cannot do it centralized. Yeah.
So perhaps I will start until Rico has unmuted.
Hello, now you can hear me?
Yes, now you are here.
Yes, sorry.
It's always a little bit.
Software told me that you're muted by the organizer, so I cannot do it. But now it's okay.
Yeah.
So thank you for the warm welcome. Let's start after this short interruption by a technical issue. I try to go to the next slide. Yes. So let me short introduce what we will tell you today. We will first have a look on the use cases in transportation and network in general to give you a frame for the discussions we have, and then Cornelia will go into the details of the techniques and talk about opportunities, about powering devices, about migration paths for integration of SPE technology in transportation industries, transportation in the sense of trains, LRVs, so light rail vehicles, and buses in special. Then we will also focus on some constraints we have, and at least on customer benefits we see with the use of this technology. So first, a short view on who we are. Just a few sentences about ANNAX. ANNAX is part of the Wabtec concern and has a 25 years history in passenger information for it's called PIS. So we provide innovative solutions for passenger information, infotainment, and CCTV in a sense of video surveillance, and we are integrating all these devices which are sometimes also from third-party suppliers into a system to provide services on board train or an LRV or in a bus. So, Connie, I let you give a few words about Belden.
Yes, Belden is an American company with brands you can see on the slide. Hirschmann is one brand of the Belgian company. We are providing and developing and producing cables. We are producing switches and I/O modules, and for sure, as you can see, also connectors. So Belden has all the parts from the connector to the switch for the whole network, and we started activities in all of our brands now.
Okay, thank you. So we will start with the overview of a network in the train. So we have modern trains have a minimum 2 IP networks today. We are normally talking about the train control management system called TCMS for the safety relevant parts, and we have an information network for the non-safety relevant parts. Like we said, what is ANNAX delivering to the customers. So in the information network, we typically have several subsystems like passenger information, like video surveillance, like passenger counting also. Then infotainment could be a part of this, or entertainment if you have long distance trains, public VLAN for the customers, and sometimes other very special applications which are integrated in these networks. Then some of these we see, when I click, we see it on the right side, highlighted, this network. No, not work. Try again. And we have, yes, now we see it. In addition, we have also several field bus networks for sub-devices on the train. For example, we have here in this picture seat reservation displays, which are connected through a gateway with RS485. We will come to this use case later in a more detail also, and this is what could potentially be replaced by a new technology like SPE multi-drop, which is under definition currently. SPE itself would be a use case for sure, also for many other IP devices. We will see it in the next minutes. So we have the potential to save weight and money. This is what we will focus on if we switch a certain type of devices to the SPE technology in future. So here I want to give you a short overview about the ranges of bandwidth which are required by the devices. So we have a variation from very demanding devices, which are up to 10 gigabits, to devices which have a very low demand regarding the bandwidth, which is even below than 1 megabit. So a typical IoT devices, which you heard in the session before. Additionally, we talk about only a few devices which are very demanding, and we are talking about a big amount of devices which are not that demanding and which have the potential to be switched. So if we have a look at the first group, we are talking about the network infrastructure, in fact. So we are talking about switches, we are talking about routers, access points, perhaps an entertainment server, which has to deliver a lot of data to the end devices. As a second group, we have servers with high demand, like CCTV recorders, like an infotainment server, which has to stream, perhaps to have multiple streams in high quality. Then we have a third group, I call this PIST controller HMI. So we are talking about multiple video streams which are requested from them in the range of 100 megabits, perhaps in the past. Today, most probably 1 gigabit to have a safe connection. Then we are going into the group where we have multiple or a bigger number of devices on board. So we are talking about TFTs, we are talking about displays inside the train or also outside of the train in future. We are talking about IP cameras inside and outside. which are recorded, which are used to show streams on the cab HMI. And we are talking also about optical passenger counting sensors, which are sometimes also recorded on the video recorder, which are using stereo cameras to count the people. Then we have the next group, which is, I would say, a low bandwidth group. But we are talking here also about streaming, but audio streaming. Audio streaming is clearly below 1 megabit itself, but I would put this group into a device group which is requesting about 10 megabits. So this could be an opportunity for the coming standard with 10 megabits multi-drop SPE. So we are talking here about LED displays, we are talking about passenger communication units, we are talking also about the cab audio units, the cab infrastructure in a cab of a train, and we are talking about audio amplifiers, digital audio amplifiers, which are driving the loudspeakers, in fact. And last but not least, sorry, this is one too much. The last group is the group for the very low bandwidth devices, where we have simple passenger countings, other actors and sensors. For example, the ones we saw in the session before as an example, and we have seat reservation displays with only a very few content on it, where you have just some characters or a very small icon. So now we will focus, or I will focus first on 3 use cases referring to opportunities to apply the 10-base T1S multi-drop standard, where we see that this can simplify things. So we have the first use case, seat reservation. As I already said, we have today RS485 bus together with a gateway, which performs actually a translation of the protocol from the network protocol to the field bus protocol. So we have a break in the data communication. You have a break in security if you need to secure the communication. And SPE can deliver here as a pure IP solution. So you have the opportunity to use standard IP protocols directly. You have the availability to send data directly to the displays. And you avoid the need of this data gateway, which we have to implement today. Then the second use case we can imagine is passenger communication units. Today we have solutions for metros where you have a lot of numbers of passenger communication units in one car, which is communicating using CAN and analog audio lines. And this can again be replaced by a multi-drop bus, which allows us to simplify wiring. So you have not to wire the PCUs in a star wiring concept, but you can use the bus wiring concept instead, which makes it a lot simpler to wire the train or the car, let's say. Then the third use case we have, there we are thinking about LED displays, which are also very low bandwidth devices because you have, again, a simple content to show. Here we have had already in the past also RS485 or even RS232 in use for this type of devices. And this is again an opportunity to be replaced by SPE multi-drop solution, which can again simplify cabling, because some of our customers are today requesting a daisy chain already. So you have to put into a display additional infrastructure to allow what we see on the right button, but with the current Ethernet technology means you have to implement an embedded switch, you have 2 connectors, you have in addition also power to deliver. So we have potentially a lot of simplification here using just one connector with a potentially hybrid power, which we will see a few slides later. So in a nutshell, I will sum up what we have on this page. With SPE multi-drop, we could in future avoid field bus gateways. We can reduce numbers of switching ports because we, as you see in the right example, we have each display connecting directly to a switch. In a multi-drop environment, you reduce this. Each switching port is for sure cost. Then all IP systems will decomplex software solutions because you avoid gateways, you avoid protocol breaks. You enable also security based on standards. For example, the IEEE 802.1.x can be used to secure communication, to authenticate devices. And you can for sure also use the standard encryption protocols on the IP level, which is not possible if you have protocol breaks. In addition, to enable this, we need here some sort of topology recognition. I hope this will be included in the standard. Today on the field buses, we have some error-prone dip switch addressing, which can hopefully be omitted in future if we have something inside of the standard. All of these points will allow us to reduce efforts in a sense of time for development, in a sense of costs for the customers. So I hand over to you, Connie.
Thank you, Rico. For this deep explanation of the network within trains or general public transport, we will see later that inside of buses, some of the end devices are similar to that. Let's first have a short recap of the existing IEEE standards, and let's see how these standards match to your requirements, because perhaps some of the audience didn't have the chance to see the presentation from Matthias and to hear more about the existing standards. So let's have first a short recap. So you can see here the existing standards. You can see on the one hand the bandwidths, starting with 10 megabit long reach or 10 megabit in general, which is split into two different physical layers, one for longer cable reaches with up to 1 kilometer. And you can see the 10 megabit T1S, S for short, which means you can, this standard allows us to have a point-to-point connection up to 15 meters, or to allow us a multi-drop solution now that just exists without power over data line, up to 25 meters. In addition, we have just a 100 megabit solution with, depending on the cabling, up to 15 meters according to the standard. We have a gigabit solution, 1000 base T1 for unshielded cables up to 15 meters, which is called type A, and up to 40 meters in the standard type B for shielded cables. And there just also has finished a new standards multi-gig, which goes up to 10 gigabit. So as a recap or summary, all these bandwidth are fitting to your needs. In addition, a new you see this task force is called 802.3DA and will add some enhancements to the multi-drop segment mentioned before from your side. This standard will allow us a 10 megabit bandwidth on a bus topology. Will add more devices, as the current standard is restricted to 8 devices. We will increase the number of end devices up to at least 16 devices. The standard will now allow a cable overall cable length of 50 meters. Which is very important for us. The next feature is power distribution over that mixing segment, which will allow us to power the end devices. This new standard will also add time synchronization for that mixing segment. The target is also to define a connector for that bus topology. And that's also very important for our use case. It will be defined also for noise environment, like transportation, which is a very high requirement according the Ethernet standardization, because the train requirements are very high according immunity. So, and the time frame, this standard is planned to be finished in January 2023. On the next slide, I want to recap the mentioned hybrid power, but I think so I do not have to say much, because it's also mentioned in the previous presentation of PeriNet, and also in the previous presentation yesterday. So the hybrid power will allow us different topologies. One for sure is the point-to-point topology, but it will also allow a kind of switch topology where the switch as a power source will source the end devices with power. And it also allows us a kind of bus topology. You can see on the left side the connector interface with the 2 pins for power with the current up to 8 amp, and the data lines, which allows also a power over data line powering. I've done a short presentation or one slide to compare the possible power opportunities which just exist. In the power over data line standard, we have 2 different opportunities. One is with the classification protocol, which is similar to PoE. The other one is without CCCP, Serial Communication Classification Protocol. The third one is the hybrid power, and the fourth one is to power the end devices by separate power cables. So I compared these powering solutions and perhaps also the advantages and the disadvantages, because currently PODL, or power over data line, is restricted up to 50 watt for the end device, which will not fit to some of our end devices within trains, like outside LEDs. Hybrid power will allow us much more power, like perhaps 200 watt over 40 meters with gigabit data transmission. Or we can choose for sure the separate power, which adds a second cable for sure. In general, we have also to keep into account the power management, because from the switch perspective, we have to ensure that all the devices are powered, and perhaps in that case we have perhaps some devices have dynamic power, so or by dynamic power changes, so we have to do a power management. You can see the comparison on that only for the SCCP protocol, or with the SCCP protocol, the power management can be done. In the other cases, it's more like engineered power management. So the integrator has to ensure that the overall available power is available for the devices. So coming to a possible migration path on the next slide. As you have just shown, the current situation is that you have RS485 bus, or sometimes also CAN, and industrial Ethernet with PoE. That means that are the current protocols you are using within the car. You are using 100,000 base T with Cat5e cables and with a possible cable length up to 100 meters. You are using power over Ethernet, and sometimes for displays you are using also separate power. As a next step, we are thinking we can add single pair Ethernet with POODLE and hybrid power to some of the devices. That means we have still the RS485 bus. We are migrating the 100 and 1000 base T1 interfaces to T1 interfaces to single pair up to 40 meters. We are integrating power over data line, or in some cases hybrid power. And as a next step, we can also integrate power over data line in conjunction with multi-drop. After the 802.3 DA standard was published. And that allow us to replace the gateways and the RS485 with 10 base T1S multi-drop with POODLE. Or in some cases, we still have point-to-point connections. So the others are as mentioned before. So coming back to your network you have shown us before, Rico. Let's now discuss the network example, and let's see how SPE can be integrated into that network. So you have shown us the Ethernet switches which are connected, or the TFT monitors which are connected currently over Ethernet to the switches, and these connection can be replaced, as mentioned before, by 100 and 1000 base T1 with POODLE or hybrid power. In addition, we can also connect the CAP audio unit with also 100 and 1000 base T1 interfaces and POODLE. Or in addition, we can choose also 10 base T1S with POODLE as a point-to-point connection. That could be a first step to integrate single pair Ethernet into a train. Let's come to a possible second step. I call it possible second step because there are some constraints which I want to mention later. In that case, we can also migrate the switch-to-switch communication, or the communication between the switches and the cellular routers and the VLAN access points to 1000 base T1 type B, or also multi-gig T1 with or without POODLE. That would be a possible second step to integrate single pair Ethernet within the car. But there are some constraints, especially looking at the car coupling, because the connector for the car coupling is not designed to fulfill the high frequency requirements of single pair Ethernet, especially up to 600 megahertz for gigabit Ethernet over single pair. So that is a topic we still have to approve. So a third step will to add the 10BASE-T1S with hybrid power as a point-to-point connection to the outside LED displays, and also to the audio amplifier, because both devices have a need of much power, about 100 watt. So Poodle isn't able to fulfill this power need. So hybrid power would be a good solution for that. In addition, we can add later, after the 802.3 DA standard is established, add the cabin audio, or also, as shown before, the LED displays for the seat reservation with 10BASE-T1S multi-drop with Poodle to our network. I want to add also some constraints looking at that. As you can see, the overall length of one car or couch of a train is about 25 meters. Typically, the switches are installed nearby the door. So as you can imagine, or as we discussed before, Rico, that will need that we have 1000BASE-T1 type B silicon for that, because the overall cable length increases the 15-meter restriction, and for that we will need a type B silicon, which is specified for type B with shielded cables. In addition, to realize our plan is that we need a M12 hybrid connector for the step 3 with enough current to supply the LED displays or the audio or the amplifier. And as you also have mentioned before, we would need the 802.3 DA standard with the enhancements of Poodle on the mixing segment. To save costs, then we can connect the LED displays for the seat reservation directly to the switch, and we can cancel the gateway. And in addition, we can source all the displays over Poodle. For that, for sure, topology recognition would be helpful. Was too fast. The next slide. I will show in short time a bus network, how it is established today or in future. In general, we will have a central unit, the assistant driver unit in front, and to that unit a first switch is connected, and for some longer buses or some articulated buses, we have a second switch in line. And we can do it in the same way because many end devices are, which we mentioned before, are also used in buses, like cameras, displays, passenger counters. These devices can be connected with point-to-point single pair Ethernet connection for 100 and 1000BASE-T1. And the amplifier we see also in buses can be connected with 10BASE-T1S with Poodle. And in addition, we have also some smaller devices, tickets, ticket machine, PCU, passenger counting units, displays, which can be connected over a 10 megabit multi-drop segment. Coming to the benefits for the customer, because why you explained in some at the beginning, we can cancel the gateways. We will see an easier cable assembly because we have less twisted pairs. In some cases, the cabling would become easier because you do not have to do daisy chain or star topology. But in addition, in summary, for the transportation market, especially for e-transportation, weight is a big topic. So I summarized this in one slide, the background for that. That means the weight with the speed, and this will be summarized to the needed battery capacity. So less weight will lead to a smaller battery for e-transportation. I will show you some figures for that. How is the rate reduction in some numbers or percentages? We compared this, especially the cables. You can see a railway cable, 100 megabit, and we will see 49% in rate reduction to a single pair Ethernet cable for that. It's similar because in the train we have also 10G connections for VLAN access points or other end devices. In that case, we will see also a weight reduction of 55%. In addition to the weight, installation room is also a big topic within trains. So the bending radius improvement is also an advantage I want to mention, because this bending radius is reduced about 30%. And also the outer diameter of the cable will be reduced about 30%. That will bring us to an advantage in installation room, in weight, and allows us an easier assembly of the cord sets in comparison with the multi-pair Ethernet installations. But not only the weight, also from the cost perspective. We expect after a ramp up that single pair Ethernet cable can reduce the costs for cable with about 25% for 100 megabit devices, which will leads us also to a cheaper Ethernet and communication interface within trains. So I think so we come now to the end. Thank you very much. I will show you also the contact information of Rico and myself, and want to finish the presentation and thank you for the possibility to show us this use case and this possible migration path within train networks. Are there any questions coming up?
Hello, Cornelia. Hello, Rico. Thanks for this very nice presentation. And one of the benefits you also pointed out, we can confirm this when we go to the railway fair, the InnoTrans 2 years ago, we also had discussions with big railway operators, and the calculation they did was they can save around 15 to 20,000 euros over the lifetime of a train of 10 or 15 years. By each kilogram they can reduce in the installed cable or other equipment. So that's really a big issue, what also you pointed out. So if I look to the questions coming in, one moment. One question coming in regarding the gigabit transmission and the needed semiconductors for it. Also, you mentioned it, it's a lack in the offering of the semiconductor industry at the moment for the Type B, so the 40-meter channel. Do you have some feedback on it? If not, I think we can also give this question in the afternoon to the semiconductor guys, so I keep it in mind. But if you have some feedback for this too.
We are in contact with the semiconductor manufacturer. Some of them have planned to support Type B, but currently I do not have any specified physical layer which specified Type B. But we have done some tests with current existing semi-silicons, and it seems that 40-meter with shielded cables defined in the industry and with the defined connectors will allow us to achieve the 40 meters. But currently 40 meters are not specified, and that is a big issue for that use case, because as you can imagine, the overall cable length with a car length of 25 meters will increase the 15 meters or will reach up to 40 meters.
Yeah, so it's also a point we have to discuss a little bit more in detail and with market volume with the semiconductor industry, but more and more applications are coming out for 40 meters. So thanks for your answer here. And as a second question coming up, it goes very in detail to the use case of multi-drop, and the customer asking here, how does the audio streaming behave when the communication units are connected to the network via SPE multi-drop? Is the latency and the jitter on the multi-drop bus so low that the stable audio connection can be guaranteed without large buffers? So it was also use cases you show up multi-drop with audio. Can you have some answer for this question coming up from the audience?
Yes, I can answer that question. This depends a little bit on the number of end devices on the bus. Currently, we see within a car, Rico, you will correct me, how many audio devices you will see within the car?
Yes, I mean, actually, we are talking about passenger communication units. So you have most probably one per door or door pair. So you have, and today we see in maximum 4 or 6 ECUs coming in a car. And if you do this in 2 segments of multi-drop, we have in maximum 3 devices on one bus, which should be handleable. And we are talking about frame size with 10 milliseconds together with a buffer with 3 frames. So we can easily jump over jitters or let's say delays, which are above 10 milliseconds or around 10 milliseconds. So it should not be an issue with this number of devices.
Yeah. The 10 megabit sounds always so slow, but it's already a speed where you can transmit video and audio data in a good quality or already is. Okay, so thanks a lot for your very detailed presentations, this general use cases and how to combine it with the existing technologies. I also like what you pointed out, the different powering solutions, because now single pair Ethernet is the technology to go to the field devices. That's why we have also to keep in mind not only the right selection of the protocol and the speed, also how to bring the power to these different devices. And I like your table. You show up all these different versions we have at the moment. And this is very important to know also for our audience, that if you start your first single pair Ethernet project, you have to think about the right speed you want to choose and also how to bring the power to your devices. And you have several options, and more we found out which combinations will be the most often used ones. So thanks so far for this very nice presentation and all this content you give to us. And I thank you, and we stay in contact and we'll see us soon. And we make now a very short break up to 11:15 when we go to the last session before the lunch break, and where we will see how to use single pair Ethernet also in process industry. And so see you soon. Take a coffee or something to drink. Have a short rest. See you soon. Thanks again for both of you. Bye-bye.
Thank you. Bye.
Thank you. Bye.
Bye.